Okay, so this is your difference of squares extra practice video. Um, Again, this is just one of those things that with time and practice comes. There's no secret teacher way for me to try to dump it into your head. There's no magic way your tutor's going to get you to know it versus your friends. It's just something that comes with practice, something that comes with time. So this worksheet is on Schoology. I am going to do the highlighted ones, and you are going to do the other ones if you need extra practice. I'm not going to do all of them because there is not really any difference to how you do these problems besides applying them to the formula. So if you remember, the difference of squares is when you have two things that are squared subtracted from each other. This does not work for positives, and it becomes a minus b times a plus b. And the biggest mistake I still have students asking me, Mr. Ducharme, I have a squared plus b squared, and I'm going to do difference of squares. No, it is not a difference when there's a plus sign. It is a sum. So if it's a squared plus b squared, that is a no. That does not work. So let's start with example 1. Example 1 is 9x squared minus 1. So the basic steps to this is to try to figure out what the square root of each part is. So if you look, 9x squared is just 3x squared. Whoa, I say squared and I write cubed. Doofus. And then 1 squared. So when I plug this into the formula, because now I have something squared minus something squared, you get 3x minus 1 times 3x plus 1. And look, nothing to it. That's it. That is how you factor using difference of squares. There's nothing crazy that I can really throw at you. So let's look at 7. Now, I'm looking at 7, I'm like, I don't really recognize those as perfect squares. Well, that's because we have to do the first step. The first step to every single time we factor is factoring out a greatest common factor, which in this case is 5. So I'm going to factor out a 5, and I'm left with 36m squared minus 1. Hey, now I have the difference of two squares. And notice that the square root of 36m squared is 6m, and then the square root of 1 is 1, so 6m minus 1, 6m plus 1. I can't forget that 5 out front because it is the greatest common factor, and boom, I am done. And my next example is going to be real quick, because I look at it and it's 25x squared plus 16y squared. Whoa, there's a plus. We cannot use the difference of squares. No. So this is not factorable. Not factorable. Silly plus. And last but not least, woo, a hard one, a challenging one, a good example. So I'm looking at 21, and I'm first of all checking for greatest common factors. I don't see any. I do know that this is 6a squared minus 5b squared because something to the fourth power. So I'm going to rewrite this. This is going to require a couple of extra steps. As 6a squared minus 5b squared times 6a squared plus 5b squared. So again, I just found the square root of each part. Oh, I'm just double checking, but I don't think that's a difference of squares. That doesn't help me very much because otherwise I have to get roots. So I'm done. Woo! However, while I'm here, let's just do this one. This one's a tad more challenging. So the first thing I do is I always check for a greatest common factor. There is a greatest common factor. It is 2r. They both share a 2 and they both share an r. So I'm left with x to the fourth minus 36y to the fourth. I am then going to do difference of squares. Now the square root of x to the fourth is x squared, and then 6y squared, and then x squared plus 6y squared. And again, I got the 6y squared because it's the square root of 36y to the fourth. I might just double checking because sometimes it might happen. I have another subtraction with some squares in it, but 6 does not make something nice, so I can't keep going, so I am done. I don't know why I wrote done over here. Who does that? Let me erase that. Move this down because I'm crazy. It needs to be organized. And there's nothing really to it. Just do some more practice. Start up here at the easier ones that have GCFs and that are all squared. Move your way up to the more challenging ones with two variables that are to the fourth, but it's all the same principle. You're just looking for the square root of each part, doing the minus and the plus, making sure that there's not a plus in the middle and the beginning because that doesn't work. And yeah, thanks for listening.